This is project 4A, which was called shopping, which means it sounded fun from the beginning. And if I just run this code right here, you can see that the data set for it had about 12,330 entries, out of which it got 4,000 correct and 800 incorrect. Now that translates to a true positive rate of about 38 and about a true negative rate of about 90 in this case. Now if we run this again, you can see that there's always slightly different values for the true positive, true negative, correct and incorrect numbers, and that's simply because every time you run this code, the program or the model selects slightly different subsets for the training and the test sets, so that's why you get these differences. But overall, you always get like a true positive rate of about 40 and a true negative rate of about 90. Okay, so one of the first things I did was I imported the pandas and NumPy module because I just like working with any kind of tabular data with pandas because it makes it so easy. So after importing the data set with pandas, I just checked the column shape or the column number and what columns they were, the shape, which means the number of rows and columns, and I also iterated over all columns and printed out the different unique values and what they were. So this step right here was mainly interesting to me because later on we're supposed to change certain column values, especially for the month column, the weekend column, the returning customer or returning visitor column. So I just wanted to make sure that all values that are in there are actually valid and what they are to change them correctly later on. There's also an alternative I tried to use in pandas, which is to read the data set into a variable using the CSV reader, but I just like pandas a lot better. Okay, so the first thing I did for the load data function was I read the data into the variable using pandas. Then to change the different columns, so the month column, visitor type, weekend, and revenue, I always use the mapping function where either I just pass the dictionary or I use different types of lambda functions to do this. Then I created two lists, one for all the columns that were supposed to be integers and one for all the columns that were supposed to be floats. And I iterated over them, just checked if the D type, so the data type, was correct, and if it wasn't, I converted it to the correct one, but they were correct. Then I subsetted the data frame into two sets, the evidence, which contained all the first 17 columns, and finally the labels, which were the results, which was stored in the last columns, and converted this to a list. And yeah, these two, the list of lists and the list, they were returned from this function. Now for the train model function, again, two lists were passed, the evidence and label list, which were both training set lists. And this is pretty simple, so you just initiate or create a model using the k-neighbors classifier from the library, and you use the n, so the n nearest neighbors, we just used one, so you put this here, then you fit the model using the evidence and the labels that were provided by the function, and you return that model. Finally, in the evaluation or evaluate function, we were supposed to evaluate how good that model actually works. So for this, I created two variables, positives and negatives, where I stored the numbers of positives and negatives from the actual results. And I also created two variables, sense and spec, to calculate sensitivity and specificity. So I iterated over the actual labels and over the predictions, which I zipped together because they were of the same length, so that works. And then I checked if the label, so the actual value, was 1 or 0, and I added or increased the sense and the spec variable accordingly. Finally, I divided the sense and specs divided by the positive and negatives and got the sensitivity and specificity, which is what we see later on in the terminal right here.